Hello viewers, in this episode we will be looking at the 2020 GCE Science Paper 1 Section B. And in our Section B, we know that Section B always carries 40 marks. However, we are not going to do the whole Section B in one single video, but I have divided it into two videos, and this is the first of the two videos. So the first question is question B1. Question B1 reads, an object of mass 75 kilograms on Earth is taken to the moon where the gravitational field strength is 1.6 newtons per kilograms. An object of mass 75 kilograms on Earth is taken to the moon where the gravitational field strength is 1.6 newtons per kilograms. What is the mass of the object on the moon? What is the mass of the object on the moon? Basically, this question is just trying to assess whether you understand how mass behaves from one point to another. And in certain cases, it's trying to test you whether you are able to differentiate between mass and weight. Now, it is a very known fact that mass is the quantity of matter in a given object. So the quantity of matter, it means the amount of matter given in an object. Now, if we look at the amount of matter, whether I was to move an object from point A to point B, the amount of matter, as long as I do not remove anything from the object, the amount of matter remains the same. It therefore means that the mass of an object remains the same regardless of the location where it has been taken. In this case, we can say that the mass on Earth is equal to the mass on the moon. And since we've been given that the mass on Earth is 75 kilograms, therefore the mass on the moon will also be 75 kilograms. And there we have our 75 kilograms. We go to B. B, calculate the weight of the object on the moon. Calculate the weight of the object on the moon. So here basically we have to calculate now the weight of the object. Now remember, the weight of an object depends on two things. One, it depends on the mass of the object. Secondly, it depends on the gravitational field strength of the heavenly body. In this case, we are talking about the acceleration due to gravity on the moon. So first and foremost, we're going to write our formula, which is weight is equal to mass times the acceleration due to gravity, g. Then we are going to do our substitution, bearing in mind that we have been given that the mass is 75 kilograms and the acceleration due to gravity is 1.6 newtons per kilograms. So when we substitute, we have weight is equal to 75 times 1.6. Now 75 times 1.6 surely gives us 120. Remember, the units for weight is newton, therefore it is going to be 120 newtons. Please do not forget, it is a common practice that when solving, people will write the correct units, but when actually writing in the space provided for the answer, somebody forgets to write the unit. So it is going to be 120 newtons. 120 newtons. So there we have our 2 marks. Then we go to C. C is saying, give two differences between mass and weight. Give two differences between mass and weight. Now here we have so many differences between mass and weight. One of them is that mass is measured in kilograms while weight is measured in newtons. The second being that mass is a scalar quantity while weight is a vector quantity. The other can be mass is measured using a spring balance. Mass is measured using a beam balance, while weight is measured using a spring balance. Remember, mass is measured using a beam balance, while weight is measured using a spring balance. The other one can be mass is constant while weight changes from place to place. Now, each time you write differences, this is a comparison statement. So you need to show that you are comparing the two things. You cannot write mass is a vector quantity while weight is measured using a spring balance. Automatically, there you get it wrong because you are comparing two different quantities. So any of the answers that I have mentioned above will score. So I'll go for mass is a scalar quantity while weight is a vector quantity. The while there is a comparison. The second, mass is measured in kilograms while weight is measured in newtons. So whichever from the ones I actually mentioned above will score. We now turn our attention to question B2. Question B2 reads, a bullet of mass 50 grams moving with an initial speed of 500 meters per second penetrates a wall and comes to rest in 0.2 seconds. A bullet of mass 50 grams moving with an initial speed of 500 meters per second penetrates a wall and comes to rest in 0.2 seconds. A. Calculate the deceleration of the bullet over the 0.2 seconds. Dear viewers, it is a common practice that people will they know that deceleration is actually acceleration. Yes, we do not dispute that deceleration is acceleration, but deceleration is negative acceleration. When the speed of an object keeps reducing, it means it is decelerating. If the speed of the object keeps increasing, then it is accelerating. So deceleration is the opposite of acceleration. Therefore, it is important to take this point. Deceleration is equal to negative acceleration. Now, what this means is that to the formula of acceleration, we are going to have deceleration is equal to negative v minus u over t. Now, if we were to actually multiply the negative throughout, we are going to find ourselves with a situation where we have deceleration is equal to initial velocity minus final velocity divided by time, like that. Then we are now going to substitute. Remember, initially the bullet is moving with a speed of 500 meters per second. So u is 500 and it comes to rest. It comes to rest. It means the final velocity is 0 meters per second. So if we substitute that, we have 500 minus 0 over 0.2. Now 500 minus 0 is 500. Therefore, we have 500 divided by 0.2. Now, what is 500 divided by 0.2? In mathematics, I was taught that if we have 0 point something in the denominator or in the numerator, you multiply it. Let's say, because this one it only has one decimal place in the denominator, we multiply it by 10. So we'll have 5,000 over 2. Then 5,000 divided by 2, that gives us 2,500. So 2,500 meters per second squared. Never forget the units. 2,500 meters per second squared. That is the deceleration. Positive. If it was acceleration, if we had used the formula for acceleration directly, we would have found a negative answer. Therefore, when shifting the answer to the slot given where we place our answer, we should have multiply it by negative, which should have become positive also. So there we have it. So we have deceleration is equal to 2,500 meters per second squared. That, let's turn our attention to B. B is saying determine the retarding force acting on the bullet. Determine the retarding force acting on the bullet. Determine the retarding force acting on the bullet. Retarding force, we just talking about force. And from Newton's second law of motion, we know that the net force acting on an object is directly proportional to the acceleration. Therefore, that actually gives us the formula for finding force. So force is equal to mass times acceleration. So we know that the mass of the object is 50 grams. Now, whenever we are solving questions involving mass or force, we are not supposed to use mass which is in any other units apart from kilograms. So we need to convert the 50 grams to kilograms. So we have mass is equal to 50 grams divided by 1000 grams per kilogram. So the grams will cancel, and because the kilogram is under, it comes on top, and we cancel one of the 0 from the 50 and one of the zeros from the 1000, so it becomes 5 over 100. Now 5 over 100 will be 0.05 kilograms. So we have 0.05 as our mass. Acceleration, we had found it to be 2,500. So we have 0.05. So we are now going to substitute 0.05 times 2,500. This actually gives us 125 newtons. Its force, newtons. So 0.05 times 2,500 gives us 125 newtons. So 125 newtons is our retarding force. So this is the force that was used to bring the bullet from a speed of 500 meters per second to 0 within 0.2 seconds. So finally, we write that as 125 newtons. Or correct units, forget units, forget the 1 mark for the final answer there. So we now turn our attention to question B3. B3 reads, figure B3.1 below shows a pulley system. Figure B3.1 shows a pulley system. So this is our pulley system, and basically when we look at pulleys, the most obvious thing you can get from pulleys is we can count the number of pulleys. We can also determine the number of ropes supporting the load. We see the load there and the effort is pointing downwards. So that's our pulley. Now let's look at the first question. The first question is saying, which is A, state the velocity ratio of the pulley shown in figure B3.1 above. So state the velocity ratio of the pulley system, of the pulley shown in figure B3.1 above. Now, the secret to determining the velocity ratio of any pulley system is one. You need to know how to count the number of strings supporting the load. It's never about the number of pulleys. It's never about the number of pulleys. The number of pulleys, as for most questions that are asked, we will tally with the velocity ratio. However, if you take away this effort and let it point upwards, if the effort is coming from the lower pulley, going upwards, then the number of pulleys will not work. But the only thing that helps or that works all the time is the number of strings supporting the load. So we have the load there as 120. This load is connected to the lower pulley. Now the lower pulley has got two strings attached to it. So what we basically do is we draw a line between the upper pulley and the lower pulley. Now after drawing this line, we are then going to count the number of strings this line has cut. So we have one there and we have the second one there. So we are basically having two strings that are supporting the load directly. It therefore means that our velocity ratio in this case, our velocity ratio is going to be equal to 2 because we only have two strings supporting the load. Two strings supporting the load. So the velocity ratio there is 2. And because it's that simple, no wonder only a single mark is given to that. Let's now go to B. B is saying if the efficiency of the pulley is 75%, if the efficiency of the pulley is 75%, what is its mechanical advantage? What is its mechanical advantage? Now, we know that the formula for efficiency is equal to mechanical advantage divided by velocity ratio times 100%. So there we are. Efficiency is equal to mechanical advantage over velocity ratio times 100%. Now, if we were to substitute all this information, we know that the velocity ratio is 2. We know the efficiency is 75%. So this will translate to that. Now, 75% is equal to mechanical advantage over 2, which is the velocity ratio, times 100%. Now, 2 into 100 is 50. The percent on this side of the equal sign and the percent on the other side will cancel out. Now, it's very important that the percentages cancel out because the unit for our final answer, if they do not cancel out, will be percent. And we know that mechanical advantage has no units. So once we have that, we are now going to have mechanical advantage times 50, which will be 50 MA, is equal to 75. So there. Now, 50 MA, we now divide both sides by 50, which is going to be on the mechanical advantage side, the 50 goes. Now on the 75, we say now 75 divided by 50. 75 divided by 50 is going to give us 1.5. So we have 1.5 there. So therefore, our mechanical advantage is equal to 1.5. So that is that. Mechanical advantage has no units because units cancel out. So if we had forces like load divided by effort, the newtons will definitely cancel out and leave it as just a mere number. Yes. Let's now turn our attention to C. C is if the load is 120 newtons, what is the size of the effort? If the load is 120 newtons, what is the size of the effort? If the load is 120. Now, to connect load to effort, we need mechanical advantage. Now we are just from finding the mechanical advantage, and we are saying the mechanical advantage is 1.5. So we've got a very rich data there. So we have mechanical advantage, we have load. The only thing we don't have is the effort. So we're going to write the formula. Mechanical advantage is equal to load divided by effort. So we know the mechanical advantage is 1.5 and we know the load is 120. So there we are. We have 1.5 is equal to 120 divided by E, which is the effort. Now, after carefully manipulating there, making E the subject of the formula, we are going to have 120 divided by 1.5. Now, 1.5 into 1.5 is 1. And 1.5 into 120 is 80. So 80 there. Remember, effort is a force. Effort is a force, so therefore it is going to be 80 newtons. So 80 newtons. Always remember, Never forget the units. Always remember. Let us now turn our attention to D. D. What work is done by the effort if the load is lifted 0.5 meters? What work is done by the effort if the load is lifted 0.5 meters? Now, again, we go back to efficiency. Efficiency will give us a clear. Now, the efficiency of a simple machine may be defined in two ways, and I've already defined one where I say the efficiency is the ratio of the mechanical advantage to the velocity ratio times 100%. So it's just a ratio. The other definition of efficiency is that efficiency is the ratio of the work done by the load to the work done by the effort times 100%. So we are going to use the definition of work to solve this particular question. So we have efficiency is equal to work done by the load divided by work done by the effort times 100%. Now, how do we calculate the work done by the load? Remember, we've been given the value of the load, and we've also now been given what? The distance with which it was lifted. So we know that the load is 120 newtons, and it moves through a distance of what? Of 0.5 meters. Now, knowing that work is equal to force times distance, we are now going to have work is equal to work done by the load is equal to 120 times 0.5. Now 120 times 0.5 is actually 60 joules. So we have 60 joules there of work done by what? By the load. Now we need to substitute that, bearing in mind that the efficiency is 70%. So we substitute that 70% is equal to 60 divided by work done by effort times 100%. The percentages cancel out on both sides. We actually now remain with 60 times 100 divided by work done by effort. Then the other side we have 75. So we will now have work done by the effort times 75, which is 75. WE is equal to 6,000. Then we're going to divide both sides by 75. So if we divide both sides by 75, it is going to be 6,000 divided by 75. Now 6,000 divided by 75 is 80. So we have 80 joules of work. So there we have 80 joules of work. This particular question had a lot of marks, and you can imagine where an examiner gives 7 marks for just one single question. It means if you fail to get this particular question, you have actually lost out a lot. So that is that. Let us now turn our attention to question B4. Question B4 reads, waves travel at a speed of 30 meters per second through a medium. If 10 waves pass through a point per second, calculate 1. Frequency of the wave. Waves travel at a speed of 30 meters per second through a medium. If 10 waves pass through a point per second, A. Calculate the 1. Frequency of the wave. Now, frequency is equal to number of waves divided by time, or number of oscillations divided by time. So we're going to write that formula as frequency is equal to n divided by t, which is the time taken for those waves to pass a given point. However, we have been told that 10 waves are passing through a point every second. So it takes 1 second for 10 waves to pass a given point. So 10 waves take 1 second. So we can write that number of waves 10, time taken 1 second. Now we substitute that into the formula. We have 10 divided by 1. Now what is 10 divided by 1? 10 divided by 1 is 10. So we have 10 hertz. 10 hertz. So the frequency is 10 hertz. So we write that there as our frequency. Then we turn our attention to number 2. Number 2, wavelength of the wave. Wavelength of the wave. Now, wavelength is actually the opposite of frequency. So, okay, wavelength is the inverse of frequency, and frequency is the inverse of wavelength. So we have wave velocity is equal to frequency times wavelength. Sorry. Let me say it again. Wavelength is not the inverse of frequency. Sorry. But wavelength can be gotten from the formula velocity of the wave is equal to frequency times the wavelength, or the wavelength is equal to the velocity of the wave divided by frequency, like that. So wavelength is equal to velocity divided by frequency. I jumbled period and misinterpreted it as wavelength. I beg your pardon. So we are going to use wavelength is equal to wave velocity divided by frequency. So if we substitute that there, we have wavelength is equal to 30, which is the velocity, divided by 10, which is the frequency. 30 divided by 10 is actually 3. So we have 3 meters. 3 meters. So wavelength is in meters. So we have 3 meters and we put it there. Now, we go to the last question, question, which is B. What does loudness of sound depend on? What does loudness of sound depend on? The loudness of sound only depends on one single property of a wave, and that is the amplitude of the wave. The higher the amplitude, the louder the sound. The lower the amplitude, the less loud the sound is. So there we have amplitude as the answer, which actually brings us to a total of 5 marks. Now, out of these 5 marks, we may have made mistakes and whatever, but what you should always take note is that mistakes are there to be made, but mistakes should not be always that you expect to make mistakes. Mistakes such as not writing the correct units should actually be not one that should be made in an exam. So always make sure that whenever you are actually answering questions, always make sure that the formula is there, the substitution is there, the answer has the correct units. Otherwise, let us now look at question B5. Question B5 reads, figure B5.1 below shows a ray of light moving from one medium to another. So we've got medium A and medium B. And light is moving from medium A, and it makes a 50-degree angle with the normal. And as it enters medium B, it makes a 65-degree angle with the edge of the medium. So basically what that means is that the angle of refraction R there is not given, but we can find the angle of refraction. So now let's look at the questions below. So A, find the angle of refraction. Find the angle of refraction. So I already marked the angle of refraction there. It's R. Now let's critically look at this scenario. The scenario is that the normal and the boundary of the two media, the normal and the boundary always makes a 90-degree angle. So 90-degree angle, and we have R and 65 occupying that 90-degree angle. It therefore means that 65 plus R gives us 90 degrees. So since it's basic mathematics, what we're going to do is, since it's 65 plus R is equal to 90, it also means that R is equal to 90 minus 65. So R is equal to 90 minus 65. Now remember, I'm writing them like this. However, it should always be in our mind that these are angles, and angles are always in degrees. Okay, so what is 90 minus 65? 90 minus 65 is 25. 25 what? 25 degrees. Therefore, the angle of refraction is 25 degrees there. So the angle of refraction is 25 degrees. Now we come to B. B is calculate the refractive index of medium B. So the refractive index of medium B, since light is coming from medium A going into medium B. So if we say refractive index N is equal to sine I, which is incident, divided by sine R, which is refractive, then we are finding the refractive index for medium B. So we are going to actually put that one down as refractive index is equal to sine I over sine R. Now, one key thing here, if you write an angle there in the formula without the degree sign, then it's wrong. It's unforgivable. It's wrong. You cannot put a mere number where an angle is supposed to be. So in this formula, the angles representing I and R should be in degrees. So our I is 50 degrees, our R is 25 degrees. So there we have the refractive index is sine 50 degrees over sine 25 degrees. Now sine 50 degrees over sine 25 degrees is 1.81. So 1.81 is sine 50 over sine 25. So that is our refractive index. Remember, refractive index has no units. So there, 1.81, which takes us to the last part of the question and the final part of our video today, which is question C. Which of the two media is denser than the other? Which of the two media is denser than the other? Let's go back to the top. Let's go back to the top. So when light enters a denser media, it bends towards the normal. When light enters a denser media, it bends towards the normal. And when it moves from a denser media to a less denser media, it bends away from the normal. So here we are expecting to find the angle that is next to the normal, which is smaller than the other. So for medium A, we've got 50 degrees. For medium B, we have R being represented by 25. So 25 is smaller than 50. Hence, medium B is denser than medium A. So we are now going to write that one there, which is medium B is denser than medium A. Thank you very much for watching this video. Don't forget to subscribe, and if possible, tell your friends about the YouTube channel so that we can actually reach as many candidates as possible who may need help in these sciences. I will be posting the physics video every week on Friday and the chemistry video every week on Tuesday. So watch out for the revision part of the 2020 GCE Science Paper 2, which will be posted on Tuesday. Thank you very much. Good night.